All right, folks, we are on to scientific notation. There we go. All right. So scientific notation, I'm sure you've seen this at some point either in middle school and maybe even some of your science classes, depending on where you guys are at. But why do we have to write numbers in scientific notation? Well, we have two reasons right here in the blue text there. One, it makes it easy to write extremely big or extremely small numbers. So if you have like a really tiny decimal or extremely large number, it's easier to use scientific notation to talk about them instead of just writing them out or saying them out loud. And to go along with that, if you do have those really big or small numbers, it makes your calculations easier because we have kind of little tricks that help us make those computations easier. But in case you kind of forgot what is scientific notation, it looks like this. It'd be like 5.7 times 10 to like the 8th. So you're going to have some number like this. And there's always going to be a decimal point right there. And this number in front of the decimal point here has to be between 1 and 9. It can never be 0, and it can't be 10 or larger. It can't be bigger than 9. So it's always going to be between 1 and 9, okay? And then you always have it in base 10, so 10 to some power. So this is scientific notation and what we'll be using today. So we'll kind of get rid of this stuff for a minute here. We're going to either go from standard form, which is how you normally see numbers, to scientific notation, all right? So this first one, we have the number in standard form. So I wanted to write it so it looks like this. So what I like to do is I like to put my decimal place first. So I'm going to put it between that 7 and the 5 because that's where I know it needs to go. So I'm going to have 7.5 times 10. Now, I need to do my little loopies. You do what you want to do, but how many times do I need to move my decimal place over? 1, 2, 3, 4, 5, 6, 7. I had to move it 7 spots. So since I moved it 7 spots, it's 10 to the power of 7. 10 to the power of 7. Okay? Let's try another one here. This time we're going from scientific notation to standard form. So I'm going to start off by writing 9.1. So 9.1. I'm not going to write my decimal because I know it's going to have to move. So now I'm going times 10 to the 5th power. So I know I have to move my decimal 5 places. So it's right here. And now I have to move it 5 spots. So 1, 2, 3, 4, 5. That's my new decimal. And now I'm going to fill in all my loopies with zeros. So that's our new answer. And if you want to maybe write it a little cleaner over here, it's 91,000. Excuse me, not even that big. It's bigger than that. Oops. 910,000 is our number. That's what that would look like. All right, let's try another one. We're going from scientific notation to standard form. So I'm going to start with my 588. I'm not going to put my decimal because I know it's going to move. But I'm going to 10 to the negative 4. And since it's negative, I'm going to go to the left. It's going to be really small. It's going to be a small decimal. So let's count in our little loopies here. Ready? There's 1, 2, 3, 4. So now I'm going to fill in my zeros. So our new number is 0.00588. All right. Let's try standard to scientific with a small decimal. So we have to move our decimal place. Let's see how many spots. So 1, 2, 3, 4, 5, 6. So we're going to have 6.1 times 10, and then since it's a small number, to the negative 6. So since we have a decimal, our exponent will be negative because that indicates that it's small. Okay, why don't you guys try these last two here? Why don't you pause the video and see if you can figure out these last two and then check your work with me. Okay, I hope that was all right for you. I'm going to do this one right now. So again, I'm going to move my decimal here. Let's see, 1, 2, 3 places. So 8.52 times 10 to the negative 3rd. because it's a small decimal and I had to move that decimal point 3 places. Now this last one, I'm going to start with my base number there, 114. I'm going 10 to the third. Here's my current decimal. I got to move it 3 places to the right. 1, 2, 3. New decimal. There we go. So that number would be 1,140. Okay, I hope that was something similar to what you've seen before, a nice little review for you. Because really what we care about is not so much that you can go back and forth from standard to scientific, because that's something you should probably have already learned at some point in your schooling. But we're more concerned is the calculations with these scientific numbers. So it's quite simple. If you're multiplying and dividing in scientific notation, we have 3 steps to follow. The first step is you either multiply or divide the numbers themselves. Okay, so depending on if you're timesing or dividing, you're going to do one of those operations. And then you're going to use the properties of exponents to change your powers of 10. And then sometimes you might need to switch your decimal if it's not in the right place, okay? So let's just start with number 1 here. So it says find the product or quotient, write your answer in scientific notation. You have 2.8 times 10 to the 7 times 1.9 times 10 to the 4th. So what you're going to do is you're going to match. I'm going to take 2.8 times 1.9. Those are our numbers. That's step 1, okay? So, right, this is just calculator work, folks. In your calculator, hit 2.8. 2.8 times 1.9, 5.32 times. Now, step 2 says properties of exponents to change our exponent. Match your tens. Our bases are the same, and we're multiplying. What do we do with our exponents? I hope you're thinking we add. So 7 plus 4 is 11. So our final answer is 5.32 times 10 to the 11th. Okay, let's try another one. So step 1, remember, multiply. So 1.3 times 4.7. Should be getting 6.11 times, now step 2, I have 9 tens there and negative 5 here, so 9 plus negative 5 should be 10 to the 4th. Hope that's what you're getting. All right, let's try another one here. 3.7 times 5.6, 3.7 times 5.6 in your calculator, folks. 20.72 times, all right, 10 to the negative second times 10 to the negative third. Negative 2 plus negative 3 is negative 5, right? Hopefully right now you're thinking, Miss Bundy, this answer isn't in scientific notation, right? Because it's 20. I want my decimal place to be over 1 spot, right? I want it to be right here. So we have to fix it. All right, so let's fix it. So in this space up here, will you please add this so you have it in your notes? So do you guys see how I have to move it to the left one? So if you move left, we add however many spaces you need. If you move right, we subtract. Star this is huge, and it's for examples like this one, okay? So, we moved it 1 to the left, so now our new answer will be 20.072 times 10, but now our exponent's going to change. So it says move left, we add, so I have to add 1 to our exponent because I moved it 1 place to the left. So negative 5 plus 1 is negative 4. And now that is our final answer there. So please, 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 if you do anything today, get this down because that's, I think, the most confusing piece. All right, let's try some division. So our process is basically the same as multiplying. We're going to first divide our numbers here. So in your calculator, 3.72 divided by 1.2 should be 3.1 times. Step 2, rules of exponents, look at your tens. Remember when you divide from yesterday, we subtract, so 8 minus 5 is 3. Double check to make sure your answer's in scientific notation, and it indeed is. We're good to go. All right, let's try another. 2.7 divided by 2.4 should be 1.125. Step 2, look at your tens, times 10, negative 5 minus negative 6. Again, if you get confused with those negatives, please use that calculator. Type in negative 5 minus negative 6. You should just be getting a 1. Final answer. Good to go. Okay, I think you should pause the video, try this one out, see how it goes. Make sure you're on par with me, then you know what's going on. Okay, I hope you tried it. I hope it was okay. I'm going to do it. 6.4 divided by 4.0, 1.6 times. Step 2, look at our exponents. Negative 4 minus 6 gives us negative 10. All right, I hope that was okay. Did you get the right answer? I hope so. All right, and then just a few word problems to round out our lesson here. It says an airplane traveled 5.7 times 10 to the 2 miles per hour for 1.4 times 10 to the 1 hours. How far did the airplane travel? So remember, for distance, you're taking your rate times time. How fast are you going for how long? So this is how fast our plane's traveling for this amount of time. So our distance equals rate times time. Here's our rate. Here's our time. So we're going to plug these into our formula. So we're going to have 5.7 times 10.2 times 1.4 times 10 to the 1. All right, let's crunch it out, folks. Multiply our numbers here. 5.7 times 1.4, 7.98. Look at our exponents with our bases of 10 times 10. 2 plus 1 is 3. There we go. Perfect. Now one more. It says the distance from Earth to the Sun is 1.5 times 10 to the 8 miles. The distance from Neptune to the Sun is 5.196 times 10 to the 9th miles. How many times further is something from, is Earth? Are we missing a word here? I think we are. It says, how many times further is Neptune to the Sun? Oh, there we go. My fault, folks. Okay, if you're looking for how many times further something is, you guys, you're typically dividing. So I want to see how much further Neptune is from the Sun than Earth. So we're going to divide. So if we crunch this one out here, we're going to have 5.196 times 10 to the 9th over 1.5 times 10 to the 8th. All right, divide it out, folks. Last one here. So 5.196 divided by 1.5 should be 3.464. Step 2, divide your base 10s times 10. 9 minus 8 is 1. So it's that many times further away from the Sun. Okay, that in a nutshell is our notes on scientific notation. Thank you for watching. Grab your worksheet from me. Okay, bye.